Yes. Thank you everyone for coming today. It's always a pleasure to be with you here. If you guys don't know me, I'm Fernando Redivo. I work with the marketing and communication aspects of the society, and I also lead the seminar series. And today we have a very special one, someone that is very well known in the field, Kenneth Cooper. I'll introduce him in a few minutes. His topic today is the dark side of projects, delays, the disruption, and disputes, and using system dynamics modeling to resolve high stakes legal cases. So I'm very excited to do this, but before we get started, just a quick reminder of the benefits of being a member of the society. So you get free access to all society seminar series, such as this one. This one is free because Kenneth himself sponsored the society, so we were able to make it this free. You also get a great discount on our conference that is coming up in July. You get full access to the society journal, the System Dynamics review, and you also get exclusive prices on our bookshops. And I'll just ask you guys to keep you guys muted if you're not speaking. Thank you. And if you're planning to learn more system dynamics modeling, it's a great way to do that because you get access to a pool of society mentors and mentorship programs, and also discount on our partners' online courses. So it's a great benefit to join the society as a member. So if you guys not familiar with the System Dynamics International Conference, it's going to happen in Frankfurt this year, but also online. So we're doing hybrid this year. You can choose if you want to attend online or in person. It's from 18th to 21st of July. And just a reminder that you can switch to a virtual ticket without any penalty by May 24th. So if you're still in doubt, if you want to join us in Frankfurt or virtually, you have this perk here that allows you to decide immediately. And also we have early bird rates. So the sooner that you buy your tickets, the cheaper it is. And member discounts are also available and scholarships. And don't forget about the summer school. It's a great way to learn system dynamics modeling with the best instructors in the field. It's happening online 2 weeks before the conference from 5 to 8 of July. And you have 2 tracks, an intro one, more basic stuff, and intermediate with a little bit more advanced skills. And don't miss out our upcoming webinars. We have one on the April 6th, the food packaging problem, a food system problem, not a packaging problem, with Sabrina Chakori. This time it's going to be different. It's at 7 p.m. It's not our usual time at 11 p.m. here in New York, because Sabrina is in Australia. So she's going to present from there. Don't miss out. You can go to systemdynamics.org/seminar series and sign up for this webinar. And this one is just a save the date. We already have it scheduled down, New Horizons of System Science, with Erica Palmer from Cornell University, Michael Watson from NASA, and Hadra Calvo Modio from Oregon State University. This is a really great opportunity. Just mark your calendars. We're gonna open registrations very soon. And just a shout out to all society sponsors. It's only through their help that we're continually able to spread the word of system dynamics. So if you want to sponsor the society, you can email me or Rebecca at office@systemdynamics.org. You can start a conversation from there. So you guys are usually familiar with Poll Everywhere. That's the platform we collect answers for the Q&A. And today I also have a few more questions to ask you. So I'm gonna go ahead and share the link on the chat. You guys can also go to pollev.com/SDS polls 877, or you can scan this QR code on your screen and you're gonna get there. Let me just go here, grab this, and I'm gonna activate soon this question that is, where are you joining us from? Oops. We already have some answers here. It's fast. Canada, Italy, Malaysia. Wow. We have a big community around the world. And today, how many people already have here in the rooms? 105. waiting for more people. Italy, USA, Nigeria, Germany, Saudi Arabia, Mauritius, the small islands. Good. It's good to see you. Good to see you all here. For me, it's one of the most amazing things about the society is that we spread throughout the world. Such a diverse community. It's beautiful. And I do have a few more questions. This is more related to the webinar today. I'm going to go ahead. I see you guys are already responding to this one. So Ken asked me to ask just 3 questions. Oops, this is not moving. The first one is slideshow. We just want to know a little bit more of our audience. We just want to know if you're a project manager or you're a business or agency manager, a professional analyst or consultant, or you're enrolled student. So let us know where you are so we get to know a little bit more this audience today. And I'm going to see answers here. Having trouble to show these answers. I go back here. Sorry. So we have, are you guys able to see, Ken? Are you seeing these answers? So most people answer that they're a professional analyst or consultant, about 52% of the crowd here consider themselves a professional analyst or consultant, followed by an enrolled student, and then business or agency manager, and a project manager, 4%. We have about 45 answers. You say it's good to have an idea. So most of our crowd today is from a professional analyst or consultant. Let me move on to the next question. Now we want to know if you have ever worked on a large scale project or manage a large project or just analyze a large project or haven't participated in a large project yet. I'm going to see responses here. And most people were saying that they manage a large project already, but this can change. Manage a large project, haven't participated in a large project yet. It's also a big part of the audience today, Ken. Okay. Let a few more seconds. You guys can share later what kind of projects you've been working lately. And we're curious to know, manage a large project. So the next question, last one, is how many projects have you guys been involved? Just to have a number, you can enter a number. People say, oof, 18, 10, 1, a range of 5 to 10. See people over hundreds over years. 50. Some people with more experience, some people that have just beginning managing projects or being involved in these large projects. 30, 100 is a lot. Well, Kenneth's been here also for a lot of experience. So I bet you're working on more than 100, Ken. So this gives us this idea that most people have worked around maybe 15, 10 projects. We do have some more experienced folks here, 50 and even more. That's good to have an idea of our audience. So for some of you, Ken doesn't need any introduction, but I'm glad to talk a few words about him. Ken is a pioneer in the system dynamics field, especially in a large project modeling, dispute and resolution. And he developed the original rework cycle model and has led analysis of over $250 billion of projects for executive clients in aerospace, shipbuilding, and construction. Ken was the president of P. Robert Associates. Today, it's known as Sage Analysis Group, one of the biggest consultancy firms in our field. And he's also a managing partner in PA Consulting, where he led hundreds of assignments for over 3 decades. And his work has been published extensively, and Ken is a 2-time Edelman Award winner. This award recognizes the best and highest impact application of all management science work in the world. Thank God Ken is semi-retired, meaning that he's able to continue spreading the word of system dynamics, being able to be with us today here. And he's still working with some selected consultant assignments. Thank you so much for having me here. Thank you so much for having Ken here. That's all from my side. Ken, if you want to take over, I'll be glad to handle the screen sharing to you.
Great. Everyone see this title slide okay?
Yeah.
Okay, great. Thanks. Thank you, Fernando. And it's good to be here with you today. And thanks to the Society for this chance, especially Rebecca, Christine, Rafat in particular, for your help and encouraging me to talk on this challenging and I think fascinating topic. It looks like many of you will already be familiar with much of the phenomena that I'll talk about based on the polling results. And for those of you who are in the business of projects or have conducted analyses of projects and perhaps even contract disputes, you know very well why I've termed this the dark side of projects. Now, regardless of how you've been around projects, I'm sure you've heard, but this project is different. Having analyzed hundreds of projects, I've heard that observation a few hundred times. And sure, there are important differences among projects, but there is one thing that we all know that many anyway, if not most, projects have in common. That's that projects tend to overrun their budgets and schedules. The only difference is usually just by how much, 10, 20%, 50%, even doubling or more. You may have your own experience based on the poll results. We've seen these kinds of phenomena in a couple of $100 billion worth of projects and programs in the defense and commercial arena, from shipbuilding, destroyers and submarines and aircraft carriers, to aerospace, electronics, aircraft programs, civil construction, power plants and refineries and tunnels. Not hard to find. And I want to acknowledge up front here that many of my observations, most of my perspective I've gained from working on the contractors side of things, as they've typically been our clients. So I'll ask you to think about with these overrun phenomena, or perhaps if you're unfortunate enough to recall, what happens to such projects, and to personalize it, what happens to the managers of those projects and to the business relationships? Well, you know, and perhaps remember projects set following the early honeymoon stage, and some concerns begin to arise, and so begins the posturing and mistrust and finger pointing, possibly leading to legal action, which is what we'll talk a bit more about today. And as that time from the start of the project progresses, the amount of energy and effort and money that goes into blame finding grows, and then grows really exponentially if you get into the legal action side of things. So, and that's exactly why I termed this the dark side. So that's what we're going to be talking today. And in particular, we're going to be talking about the phenomenon known as disruption. That is really the darkest part of the dark side. We'll define and explain disruption shortly, but first we're going to touch on the origins of contract claims, some of the legal requirements and technical challenges, and methods for analyzing cost damages in project claims. And of course, to no one's surprise, we'll be talking a bit about the dynamics of projects and of course, disruption. So I figure it probably is really about a few days or perhaps weeks to cover all of that really well. But Fernando tells me I have 40 minutes here to condense my 40 years of work. So I'm going to use some notes just to keep me on track, because I have a tendency to wander a bit, and I want to keep to that 40-minute schedule. So my objective today, to be clear, is simply to encourage more good work in this area, in the field of modeling and among contractor clients or customer clients. The first and foremost message, I hope that will be clear, is the very large value for the modelers of using their modeling skills to help improve project performance and minimize overruns, and therefore avoid disputes. And for those of you who do manage projects, you already know the great value of dispute avoidance. Let's start with one very simple reason for that, and that is the very large cost of going through a dispute. A lot of money goes to attorneys and analysts in support of a dispute, a lot of hassle complying with the required production of all those project records and reports during the discovery phase of the dispute. A lot of effort, and a lot of that's necessarily from the key project staff, because in pursuing the dispute, they are the ones who know the project best. But what that means is that, especially for the typical instance in which the project is still going on during the dispute effort, those key staff people are diverted away from working on the project where they ideally should be, and instead working on the dispute. And typically, such an effort commands an awful lot of attention from every level of management. It may not surprise you to learn that project managers and their staff get an awful lot of attention from their management superiors when the organization has 10 million, 100 million, $1 billion on the line. So with all of that cost and effort, often millions of dollars, and perhaps several years later, somebody will receive a modest percentage of what they think they are owed. But since some disputes will occur best to be well prepared. So let's take a little step back and look at some of the causes of this mess. I'll ask you to think for a moment about, aside from overruns, what other phenomenon will you think that most projects have in common? Not a trick question. It happens to be, in my view, the most pervasive cause of overruns and disputes on big projects. Well, almost all projects encounter changes. They could be design changes. We want a different generator to be used, or work scope changes. We need to add a fourth unit to that plant. There could be regulatory changes or delays of many different sorts. So given those examples, what do you suppose the chances are that a complex project is not going to encounter changes and overruns? Not very much. In a lot of cases, in fact, it's not just one or two or 10 or 20 significant changes, but often hundreds of changes, big and small. And you may have heard the phrase "death by 1,000 cuts." And all of those changes are landing on what is typically a tightly budgeted, tightly scheduled, understaffed, and stressed project. The changes impacts can really dramatically increase project costs, and quantifying the disruptive cost impact of those changes, as many of you know, is quite challenging, to put it mildly. So the key question is, who should pay for how much of the cost growth from this original, this is obviously plotting cumulative costs, from this original budgeted level of cost to what actually ends up happening in the historical condition as documented in the records. So you've got some amount of cost growth. Key issue in the dispute is who's going to pay for how much of that? Well, some of that difference is obviously the visible, measurable, direct cost of implementing the changes. So it's $2,000 for that added pipe, or 150 extra staff hours to install it. And beyond the direct impact, the sum of that remaining unexplained cost growth is disruption cost that was caused by the changes. So we're looking to figure out how much of the difference between the budget and the historical condition is owed to the contractor from the direct impact and the disruption. So let's talk about that. So disruption is that darkest part of the dark side that I noted before. It really is the most poorly understood, most debated, and in some cases the most abused aspect of damage quantification. And therefore it's really almost always the least well recovered aspect of cost damages. Even though the magnitude of disruption costs can easily be as much as or more, 2, 3, 4 times the amount of the direct impact costs. To further complicate things, disruption goes by a lot of different names in different settings. Now, some will simply refer to it as delay and disruption, also secondary impact. ripple effects, knock-on impact. But by whatever name it is used to describe it, here's the definition of disruption on a project. It is the change-induced impact on the cost of performing work that is not directly changed. So let's say that again. It's the cost impact of performing, extra cost impact of performing work that is not directly changed. So it is fundamentally about productivity loss and increased rework on the work that is not the subject of the change. So as you would, I'm sure, expect that with the magnitude of the stakes involved here, there is a host of requirements that fact finders, courts and boards and arbitrators usually insist be met. And first, of course, the approach needs to quantify the amount of disruption, the productivity loss, and the extra rework. It needs to, the method needs to describe how that disruption impact was caused by the cited change events. In some places, the change events will be referred to by the term unplanned events and conditions, or UECs. And it needs to describe that impact. The method needs to describe that impact, even though the disruption impacts could well be separated substantially in time and space from the change events. So what do I mean by that? So you may have an engineer in Boston that's working on a design change that ends up affecting a construction team's work in Germany a year later. But despite that challenge, that impact in the field or in the construction work so many months later needs to be captured in the analysis. A fundamental tenet of really any damage quantification, and certainly applies here, is that the analysis ideally will identify the amount of money that would put the damaged party in the condition that they would be but for the change's impacts. So that's as I said, isn't just applying to projects and disruption. It's a damage. It's the definition of recoverable damages in a suit. But here, this means identifying how much money is due the impacted contractor as a direct and disruptive result of the changes. And it needs the method needs to exclude the impacts of any concurrent events that are going on. These are impact costs that the contractor is not entitled to recover. So perhaps there was a labor strike during the project, or maybe a hurricane damaged a construction site. Those are impacts that are not legitimately claimable. So in sum, you need to show how the impacts happened, show that they arose from the specified changes, not from anything else, and quantify exactly how much that cost impact is. So think about that. So with those requirements in mind, think about what methods might be used to quantify project cost overrun responsibility, and not counting system dynamics for the moment. What is it that you would do? Well, some of the typical approaches that are used by contractors to assess cost damages and disruption include the what I always thought was the cleverly named total cost approach, which is to say, well, we agreed on a project budget of X, it cost Y, pay us the whole difference. And then since that didn't work very well too often, there's the equally cleverly named modified total cost approach, which is simply requesting a percentage of that difference. I've seen some contractors use an add-on factor to the direct impact costs. The first time I saw this was at a shipbuilder, and in the engineering work, they were experiencing several customer changes, and I said to the engineering manager, okay, so how is it that you're dealing with the disruption cost associated with these changes? And he said, well, oh, don't worry, we're adding 15% to each of the change costs that we identify. Well, that's interesting, since the disruption costs in that program were probably about twice the direct impact costs, as we came to learn later. But that is an approach used as an add-on factor. A fairly popular method is referred to as the measured mile approach, and in that method, they identify a part of the project that wasn't impacted by changes, and assert that the performance difference from budget on the impacted part is your fault, or the customer's fault, and to pay that difference. There are some challenges, intellectual challenges, I think, with this approach. It's particularly difficult, I think, to use in the realm of engineering rather than in a physically separable construction site, for example. And in some cases, contractors will simply hire an expert, and the expert will offer an opinion about what amount of damages are owed. Now, the customer arguments will argue, the customer will argue that, well, it didn't happen that way, or it shouldn't have happened that way, or in one particularly outrageous stance that I've seen a few times, they'll simply assert that, well, there's no such thing as those disruptive impacts. Or they'll turn it around and say, well, it was all your fault through your mismanagement. You pay us. So probably is not much of a surprise that these impact claims are often underestimated. They're typically under-recovered, and almost always involve a very contentious recovery effort. So we need a better way. And that better way is one that we've seen used on many projects. And it is the story that I'm going to tell you over the next few minutes is one that we've heard from literally hundreds of managers, and one that some of you may find familiar, at least parts of it familiar. So I will start with this. They will say, well, our engineers were working hard on the project, trying to get the work done, but their productivity was hit during the course of that effort. And furthermore, we ended up having a lot of rework to do, and not merely a few rework items, but often cycling around this rework cycle with many revisions. We've seen a lot of contractors that use letters A, B, C, D to label their subsequent rounds of revisions, and quite a few who run out of the alphabet in doing so. Some people say, well, why do you have this word quality up here? And in this context, when I started calling this, I got a lot of pushback at the start, but it is only defined as the fraction of work being done that will not require subsequent rework. So it can vary from 0 to 1. If it's low, then a lot of work cycles down here around the rework cycle. And if it's high, more work flows directly into the category of truly complete. Now, when we have an extra hour or two, we can discuss more of the really huge implications of this notion of undiscovered rework. But for now, I'll just note, as some of you already know, that undiscovered rework is responsible for much of the propagation of impacts, the snowballing of costs in other downstream phases of work, carrying out technically dependent work that contains errors, but errors that are not known to exist yet. Clearly, that is a recipe for impact costs downstream. So using that structure, a little smaller version so I can add to it. Again, I'll ask if any of you have encountered these phenomena that we'll look at in the next couple of minutes. Well, first, contractors have told us many times the customer changed and added so much work to the work to be done, or caused extra revisions to be needed. Well, that grew our estimate of the costs at completion, and without schedule relief, that meant the growing EAC, estimate of completion, meant we had to add more staff to the project in order to finish on time. But we were working in a very tight labor market. We had to use a lot of overtime to move things along more quickly. But that we understand that long stretch of overtime hurt our productivity, and the fatigue that the staff experienced led to more errors and revisions that needed to be made. And hiring in that tight labor market meant we were coming closer to scraping the bottom of the barrel in terms of available people with appropriate skills. And so we ended up having to hire staff with less experience than those that we already had on board. And the more hiring we did, the less experience we could bring in, or appropriate experience that we could bring in with the people. And that also affected the productivity and the quality of the work, again, meaning the fraction of work that did not require subsequent rework. Further, as those revisions began to pile up, again, as I noted earlier, probably working through this phenomenon of undiscovered rework, it caused even more revisions that were needed to be done. And it slowed down our information exchange with the vendors. And that led to more out of sequence work being done, and again, impacting productivity and rework quality. So every time a factor affects that oval in the middle there, the productivity and quality, it is an impact of It's an impact on the cost of performing work because you're either working less productively or reworking items more. And finally, with all of that going on and the prospect of schedule overruns and budget overruns, the pressure built up on the organization. It hurt we know that it hurt the morale of the people working on the program, and that affected their productivity. And to add insult to injury, that lower morale also increased the staff turnover. People threw up their hands and just left after in all that stress. And so that meant that we actually ended up having to hire even more people to maintain the staffing levels, and that drove down our experience levels even further. So all of these things going on in this snowballing of impacts and ever-growing costs as a result. And furthermore, those phenomena in the engineering stage triggered the late and the changing engineering product caused productivity and quality impacts out in the field or in the plant, the construction effort. And that triggered a set of productivity dynamics somewhat similar to what you see in engineering. So again, the question is whether any of this sounds familiar. A lot of times in going through this with large groups of managers in person, I will ask if there are any managers in attendance who have not seen any of those conditions, and have to tell you that very few hands go up. So if we can, so looking at this again, if we can code and test very carefully a simulation model of the project, we can work toward I think a better understanding and quantification of the productivity and rework impacts or the disruption that changes cause. So what's crucial is that you start with a model that replicates very accurately the costs and the conditions on the project that as it actually occurred. Now, let me pause to acknowledge here that saying that that's important, it involves a bit of arm waving on my part, because can be a very substantial part of the model refinement effort to get that model to be as accurate as you can make it, because you want to be able to assert with some confidence that this is a model that truly reflects the major phenomena that were going on. And the reason you want to get that accurate historical model is that we're going to take that model and run it, but with one set of differences. We're going to remove from that historical case, we're going to remove only the direct impact of the customer changes, or UECs, or whatever you will call them. We're going to, everything else about the model will stay the same, but we're going to remove the direct impact of the changes, and that yields a second simulation that I've always called the would have simulation. And all of the difference from what the simulation shows would have happened versus what actually happened is customer responsible cost impact. Why? logically, because the only thing that's different is the presence or absence of the changes from the customer. Some of that difference from the base historical condition to the would have simulation is that direct impact that was removed, and the rest of it is therefore the disruption that is made up of the lowered productivity and increased rework caused by the changes. Now, I draw these lessons or these points from about 20 major dispute analyses. Happily, that's among hundreds of projects that we've analyzed proactively. We did quite a lot of that proactive work with, for example, with Fluor Corporation. The brief story there is that we had actually worked with them on 2 or 3 big disputes, and in discussing it with the executive management, they said, this, for all the reasons that we've been through in the last 35 minutes, they said we just need to change what we're doing here. We want to avoid disputes as much as possible, and so that's what we spent several years at Fluor working on, is dispute avoidance using similar method, but forecasting change impacts and identifying ways to mitigate those impacts in the future. But the whole thing started, as some of you may know, with a model of a couple of very large programs, shipbuilding programs at Lytton or Ingalls Shipbuilding. And that was a claim against the U.S. Navy. And I'll just take an extra half a minute to point out that among our group today is actually the original inspiration for and the client of that seminal work, the then vice president of Lytton, Richard Goldbach. The field of system dynamics owes a lot to Rich, and I'm proud to say that 40 years later, he remains a great friend. But that case really paved the way, in my experience, for a lot of project modeling work to follow. Obviously, some major dispute cases, including some big civil construction, several defense programs as well, and the basic phenomena and approach remain very much the same across that wide range of projects and disputes. I'd like to make one, I think, interesting twist that we encountered. It's been 25 or 30 years ago, but back in the days of building nuclear power plants, the big issue with all the regulatory change was the extraordinary growth in costs, not by a factor of 50 or 100%, but by factors of 2, 3, 4 times the original budgets. And worked for one client where the Public Service Commission review, as they do in all geographies, evaluated what they referred to as the prudency of the construction, and if there was overruns that the Utilities Commission did not think were or were too much, they would exclude those costs from being able to be recovered in the rate base. And so this, of course, was a very large phenomenon in the with those large cost growths. In one case, we were working with a power plant, and they said, they're going to hammer us with a lot of disallowed costs because they're pointing to things that they think we did wrong. And in talking with them, we said, well, are there any things that you did that you're particularly proud of? And they said, well, yeah, several. And what we did with the model in that case was not a would have case, but a could have, where we identified those, or they identified the very good actions and that they had taken, better than average management examples. And we ran the model to show how much the plant could have cost, but for the very good actions that the contractor had taken. And they ended up with one of the smallest disallowance in the entire nuclear industry. But that is I think an interesting twist. Now, just to sum things up here, what I find to be the beauty of applying this form of system dynamics work to projects and disputes, that as we've seen, it answers the very fundamental question of that fact finders want to hear, which is what would have happened but for the specific customer changes. It doesn't include the impact of other concurrent impact sources, because that base versus the would have difference only has the difference of the customer changes removed. Clearly, using this style of model, you can quantify productivity loss as well as increased rework. They are the components of disruption, as we've seen. One thing that's very, I think, often overlooked is that the ability to quantify the effect of engineering conditions on construction, despite the fact that these effects are very often a major portion of the cost damages. So that's an important characteristic. The system dynamics modeling, I think, clearly represents self-reinforcing feedback phenomena, as we've seen in what some clients refer to as my spaghetti diagrams. So that's how that snowballing of costs occurs, is through those self-reinforcing feedback conditions. So here's a bonus that a lot of clients have taken advantage of. Very often, as I mentioned, a dispute will be occurring before the project is over. And so the modeling can simulate future impacts on the project as well. You just let it run through the simulated end of the project. And that's a helpful thing to be able to identify on not only just to identify the costs, but importantly also to help examine mitigating actions that might be taken still to lower those future costs. And by doing so, going through all that in a careful, high quality way, what we found is that the approach really can help elevate the quality of contractor-customer discussion on this otherwise very high contention issue of disruption. And so I, as I said at the outset, I encourage more work to be done, hopefully not on just on disputes, but improving, helping managers with modeling to improve the performance on projects, and then only if necessary to move into the dark side. And with that, Fernando, I will turn it back over to you. And again, thank you for the opportunity.
Thank you, Ken. Thank you. I'll put poll everywhere here for the questions. We do have a few ones. I'm sorry, we're probably going to go a little bit over time, but we do have some questions here. Here. Are you able to see this on your screen, Ken?
Yes.
Yeah, so I'm just reminding you guys, there is a link in the chat. So if you still want to send your questions, Ken is going to start replying for them now. We have a couple here. You can also download and upload the questions here, so the most popular get answered. And the first one that we have here, Ken, is the project model is a very interesting metaphor to address industrial disputes. How to deal with class action disputes like health impacts, environment impacts, etc.
Well, I can't answer that directly, not having employed modeling to deal with that. But I think if any time that you have a system that can be modeled with some confidence, if the issue at hand, as I imagine is a central issue in some of these examples cited, if the issue at hand is what would have happened or what would happen but for specific events or conditions, then yes, the metaphor would hold for those other kinds of disputes and the assessment of damages that would go with them. It seems to me.
Thanks, Ken.
If anyone has done that in our group here.
Yeah, feel free to unmute themselves and speak up. Thank you. I think it was Jorge. I don't remember who sent that question.
Pre-project. I see a pre-project question there. Yeah, let me just jump to that for a second.
Yeah.
Yes, there quite a lot. We have used, and I personally have worked with clients to to plan projects but importantly to examine what different policies or practices could be implemented to improve a baseline performance. I've not seen system dynamics used to simulate or forecast how many tons of steel or how many miles of pipe might be needed. But given that basic industrial engineering baseline forecast, I've worked on many projects before they ever started in advance of the project. One of them was for example, the F-18 Super Hornet aircraft program. We were under contract before the contractor was working on that, and that became an extraordinarily successful program. And it's not the only one. There are I think a lot of examples here among those who have been involved in project modeling.
Thanks, Ken. Moving on to the one up here. Do you think new methodologies to manage projects incorporate some of the lessons you provided over the years?
Yeah, I'm sure that there are a lot of methodologies that have that correspond to the lessons that we've seen. I mean, one of the things that we clearly were advocating for quite some time is I talked a little bit about undiscovered rework and its critical importance. Anything, almost anything that that improves the speed of discovering that undiscovered rework, so that it's not sitting there in that pool causing havoc downstream. Things to advance the pace of rework discovery are generally extremely high leverage help to a project, and certainly the advent of 3D engineering work has dramatically improved the speed of rework discovery, so that you're not discovering that, oh, well, this pipe runs through where that wall was supposed to be. When you're out building it in the field, you see it in the 3D model, and that's been around for quite a while now. But you know, perhaps there are managers on the call here today who can point to improvements and methodologies that that correspond to this question.
Thanks, Ken, and thanks, Jorge, for sending this question. Rebecca is asking, can you provide advice to other modelers who want to successfully take a specific type of model and generalize it for sale to others? Like Hugh Robert does, we haven't managed to do this in many arenas.
Yeah, I wish there were a simple answer to it. I can identify with the challenge, even in something. Maybe we just got lucky in identifying an arena of, that is to say, project management, where this fundamental set of dynamics is so consistently repeated from one setting to another. But I can empathize, because the effort that we went through back in the Pew Roberts days was one that met a lot of resistance, even within Pew Roberts. That the notion that you couldn't do this, you shouldn't, it was going to be too difficult, and then growing that area took years. It was not something that it was not a fast process. I think the ability to identify dynamics that can be shown to be similar in different settings, first of all, is a prerequisite. And I wish I had a simple answer to how to accomplish this in other arenas. It took a lot of work and quite a bit of time.
Thanks, Ken. Thanks, Rebecca, for sending the question too. And there's one here that just popped up. Would you consider the example of cyclical problems from one malfunction in the system preventable?
I'm not sure I understand the question.
Yeah. Daniela you here? Can you unmute yourself and maybe just clarify the question for Ken? Can move on to the next one while we wait for them. I entered a few questions for, since we can, and this is a quite long one. Just I understand that the core of the model that you use is essentially the one created some decades ago. Do you think that the bulk of your work has been taken, that support model, and making it work in real cases? And two, what aspects of the model have changed?
Well, thank you for the compliment in there. Well, it's certainly true that the bulk of the work that I've been involved in has been dedicated to making it work in real cases. And I think that's the highest value use of the models, is to get them applied in situations where there's real impact from the use of the model, and then ideally to extract lessons that can be generalized for even outside the context of a specific project application. I was going to tell you a story about that, but we may be a little short on time. But so what aspects of the model have changed? I think there have been a number of refinements to the structure that many people have been involved in implementing. The core of the model, with in terms of there being a rework cycle and set of phenomena involved in feedback that affects productivity and rework quality. I think those are pretty consistent factors, phenomena that remain in I think almost all project models.
Thanks, Ken. It's 10 past 12 already, and I'll let you maybe choose one last question, Ken, that you would like to answer from these ones that we have here. One is related to COVID-19 and all the less experiences that leads to a higher risk of incidents. Do you have a preference? They're both for Andres.
Yeah, I'm not. I don't have a preference. Project schedule reviews. How many of these reviews would have been used to slip additional slippage? Yeah, I'm sorry. I just don't quite understand the question.
Andres, do you want to clarify your question if you're still around here? If you're able to unmute yourself.
So basically, we were in the middle of a construction project during COVID, and when South Africa went into lockdown, immediately the contractors sent out a letter to indicate act of God. And then when we came back, the schedule discussion that happened after that was, it wasn't exactly the time that we lost for COVID. There was some additional slippage that they tried to sneak into the project. So, I think every opportunity that the contractors get to renegotiate the contract, they're going to try and put those extra slippages in. And I was just wondering if you have, if there's any thoughts on how big chance, what would be the scope of the chances that the contractors would try and take if there's an opportunity such as that to renegotiate the deadlines?
Yeah, that's a good question. I haven't experienced that in the last couple of years. But just generically, the slippage of projects is a tricky business because there are so many, as you know, there are so many costs that are involved with any time delay, so-called marching army costs, and others. The market opportunity loss, but in some cases, a slippage actually can benefit the contractor by reducing the amount of overlap in a tightly scheduled project. So I would just point to the possibility that some of the contractor costs ought to actually be reduced in the case of a slippage.
Thanks, Ken. And thanks, Andreas, for sending these questions. We are over time. Sorry, I missed my tab here. So we're just 12 here in New York. So I just want to say thank you for Ken for joining us today. This was really insightful webinar. For me, it amazes me every time how system dynamics can be applied and used for so many different fields and different industries across different organizations. And just a few final considerations, and I'll hand it over to you to some final words, Ken.
Thanks for the opportunity. I really have enjoyed the process of going back through the different cases that I've been involved in, and I hope that people will get some benefit out of the brief review we went through today, and carry on with similar and better work.
Thank you so much, Ken. We hopefully will have you again soon with another webinar with more insights.
Thank you.
More than invited to do that. My final words. Share the screen. Just reminding you guys, if you haven't seen it, that we have a new member orientation that I would like to invite you guys. This one. Sorry, it slipped away my presentation, so I'll just share this. So if you want to learn a little bit more about the member benefits, you can join us on March 24th. There are 2 times, one at 11 a.m. and I think another one at 9 p.m. We go over the benefit, resources, learning opportunities, and how to get involved in the society, and also networking opportunity. So don't miss out. And I also remind you guys about the upcoming webinar on 6th of April. You can sign up, or you can go to systemdynamics.org/seminar series, or just here events seminar series. You can find these webinars. Thank you so much. I'll just invite Rebecca for some final words too. Rebecca, are you still here?
Yep, thank you, Ken. It was really great. Great to hear about this. Appreciate your doing this for us, and also sponsoring it so that everyone could attend for free, so that it was more available to people. Thank you very, very much. Very interested in hearing about this topic.
My pleasure. Thank you.
Well, thank you so much. You guys maybe can stick around for same thing, can mute themselves to say thank you to Ken too. There's a lot of reactions in the chat, Ken, saying thanks a lot. It was a great and enlightening seminar, excellent topic and presentation. It was great to hear you. Thanks for the interesting topics. Thank you very much for the presentation. There's a lot of reactions in the chat, Ken. Same thing to you.
Thank you, Fernando, and to all of you.